Hello, how are you guys doing? So I just want to quickly talk about pulley problems. And just like hear it, I'll start by talking about some basic or classic examples of this. Imagine you have a table, and let's start with the table having no friction. You have a pulley on the table, and a rope goes over that pulley, and then has a mass on this side. And there's a mass m1 on this side too. So if we know either the masses of these objects or if we know the tension in the rope, we can figure out certain things like the acceleration, the tension itself, and sometimes the net force, so etc. Let's say this is a mass of 2 kilograms, or start off with this one being a mass of 1 kilogram and this one being a mass of 2 kilograms. Do you think this system will move, or do you think it will stay at rest when if someone was holding a hand on this object, and when they take the hand away, will it move or will it stay at rest? What do you guys think? You can pause it for a bit and see. So this object has a mass of 1 kilogram, but the force acting on it is the force of gravity, and therefore that force is 9.8 times 1 newtons. So 9.8 times 1 is still 9.8 newtons. This is only 2 kilograms. So ask yourself, is a force of 9.8 newtons able to pull a force of 2 kilograms without any friction? The answer is yes. So the answer was yes, the system would move if there was no friction. But even if there was friction, this force is bigger than this mass, so the object would still move. Now, thinking of the acceleration of the system, we see that the system will be moving downwards. So if it's moving downwards, what is the acceleration of the system? Let's see. We can consider this mass only. The forces acting on that mass, if I look at free body diagram of that mass, is it has the force of gravity acting downwards, force of tension acting upwards. The force of gravity, it's Newton's second law equation, F net equals ma, will be the force of gravity minus the force of tension, which I'll just use T is equal to the mass of that singular object times acceleration. Someone else can examine this as a whole system. As a whole system, I can draw a free body diagram for the entire system, and that entire system will have a mass of 3 kilograms. Then I'll ask myself, what forces are acting downwards on this system? It's the 9.8 newtons. What forces are acting upwards on this system? It's the tension in that rope. Because this force, fortunately this tension here is the same tension here because it's the same rope, but there is no other vertical force besides the tension. So I can still use that equation to find the acceleration or the tension. So if I use this one over here, 9.8 minus tension equals A. So 9.8 minus tension equals A. I see that tension is equal to 9.8 minus A. That doesn't help me find the acceleration. What about this second object? This object here. There is no force acting horizontally on the object going this side. So the net force acting on that object is simply the tension. So according to that one, according to this object on itself alone, the forces acting horizontally are, you have tension, and then on the other side, on this direction, there is no force at all. So for that object, the tension is equal to its mass times acceleration, and therefore tension is equal to 2 times acceleration. Now, having those two equations, I can come and substitute for tension in this equation. If I substitute for tension, I'll have, because tension is 2A, so 2A is equal to 9.8 minus A. Then I end up with 3A is equal to 9.8 and acceleration as 9.8 divided by 3. When I have the acceleration, I can substitute it here to find the tension acting on this in the rope in this system. Now if I had used this analysis of the whole system, let's just see how that works out. You have force of gravity 9.8 newtons, and you have the tension force, so the equation would still be 9.8 minus T is equal to the mass of the whole system is 3 times A. But you would still need one of the other equations to be able to solve for both tension and acceleration, because the system is if I'm looking at the whole system, the forces that are acting on this entire system are just, sorry, I was wrong here, even here, this tension is an internal force if I'm looking at the entire system, and I'm going to explain that a little bit. This tension is an internal force because it is not causing the motion of the system, because this tension is equal to the tension here, so basically it's an internal force that cancels out. The only external force on the system and the net force on the system is this force of gravity. So the free body diagram for the entire system would simply be this, because if I put tension up here, I would have to put another arrow that's equal to the tension. That would mean that it cancels out. So my apologies there. The tension is an internal force on the system, so it doesn't affect the motion. But if I'm looking at the entire system and I want to see what forces affect its motion, then the only external force on the system is the 9.8 newtons, and its equation of motion would be F net is equal to mass times acceleration. So therefore F net being 9.8 equals the mass of the whole system is 3 times acceleration, and I still end up getting the same value of the acceleration of the system, which I can substitute in one of the two equations. Fg minus T equals 1A for the 1 kilogram object to find its tension, to find the tension in the system. So T would in this case be Fg minus A, which is 9.8 minus what you get from that answer for acceleration. Okay, let's look at another example. This time I still have a table, pulley, another pulley, big mass, 4 kilograms. I have another mass here, let's call it 8 kilograms, and I have another mass here that is 2 kilograms. So I think we can see that the system will accelerate to the right, and in this case it will accelerate downwards, and in this case it will accelerate upwards. So the question is the same: what is the tension in the two ropes? Since these ropes are splitting up, we're going to consider them as different ropes. So we'll call that T1 and we'll call this T2. Even if the same type of rope had been used, then the tensions experienced in each of those sections of the ropes would be different, because the ropes are not pulling the same weight or not experiencing the same forces. We have Fg here, and we also have Fg here, which for this one is 2 times 9.8, 19.6, and for this one it's 8 times 9.8, which is, you guys find out. So the easiest approach is to look at it as a whole system and then ask yourself, what are the external forces on the whole system? So as a whole system, the external forces are this force of gravity, and so this force of gravity is an external force, and this force of gravity is also an external force. All these other tensions are internal forces, because on their own they cannot cause motion of the system. What I mean is, if these two were not there, the tensions on their own would not cause the 4 kilogram mass to move. So the other force which is acting in the opposite direction of this one, the only other external force is this Fg, which I'm going to represent with this as Fg1, not 2, and this is Fg1. And that one was 19.6, and this one is 8 times 9.8, which you still haven't told me the answer. So the equation of motion, F net is equal to ma. F net is going to be 8 times 9.8 minus 2 times 9.8, which I can simplify to be 10.8 into 8 minus 2 is equal to mass of the entire system. The entire system is 6 plus 8, which is 14. Yeah. Yes, 14 kilograms times acceleration. So this right away gives me the acceleration of the system. I can see that acceleration is 9.8 times 6 over 14. When I have the acceleration, I can now consider one of the objects, or actually either of the objects. So if I consider this 8 kilogram object, if I consider the 8 kilogram object, on itself, its force of gravity is Fg2, and the only force acting upwards on it is T1. And I know that the acceleration of the system is the same, so its equation is F net equals ma. F net is going to be the Fg2 minus the tension 1 equals mass of only that object, which is 8, times acceleration of the entire system, which I calculated here. So the only unknown, I hope you can see, the only unknown is going to be T1, because we know Fg2 is 9.8 times 8 minus T1 is equal to 8, 9.8 times 6 over 14. You guys work out the math and find the answers. So this helps me get T1. I can do the same exact thing to get T2. So if I do the same thing for this, I can get T2. The equation of, or the free body diagram for that 2 kilogram mass is going to be force of gravity here, which is 2 times 9.8, and tension 2. Now this object, this is even wrong, this object is going upwards, so its free body diagram should represent that the upward force is bigger than the downward force, because I know that its acceleration is upwards. So its equation of motion will be T2 minus Fg2 equals 2a, because its mass is 2. And remember, I'm using the equation F net is equal to ma. So substitute, I can see that T2 will be 2a plus Fg2, which 2 I know acceleration, and Fg is 2 times 9.8. Substitute and find the value of the tension. So this is what I want you to try. One example is here. I'm going to give you 2 examples. Let's say you have a 5 kilogram mass, you have a pulley that's very high, pulley, rope, 4 kilogram mass, and this side you have this is a 3 kilogram mass, and this time there is friction on the table. There's a friction force on the table. Again, the system is moving to the right, but there's a friction force on the table, and the value of that friction force is 15 newtons. Right? Your task is to find tension 1, and also to find tension 2, and also the acceleration of the system. So you're finding 1 acceleration, 2 the values of T1 and T2. So that's one of 2 questions. The second question is also a simple one. You have a pulley, it's tied to some building used to lift things. You have a rope that goes over a pulley. On this side there's lifting material that is 50 kgs, and on this side the counterweight is let's say 45 kgs. You're supposed to find A, acceleration of the system, and B, tension in the rope. And if you have time, if this is not too much work already, we can make this system interesting where we have a pulley there that goes over another pulley, you know. So let's say you have 1 kilogram here, 1 kilogram mass, oops. You have 1 kilogram, this is 1 kilogram, and this is 2 kilograms. And then on this side you have just 1 mass, and it's 4 kilograms. So here you're going to have 2 separate tensions. That can be tension 1, this is the same tension 1, and then this is going to be a different tension. So yeah, try. If you can do this, good. If you can't, we'll go over it in the video call on Monday. But yeah, still again finding acceleration and B, the tensions. Alright, I hope this wasn't too much. Yeah, bye.